Hello, we are Team Remedion. My name is Aaron Fair and my teammate is Michael Marcello. For our senior capstone project, we worked with Remedion to adapt their municipal hydroelectric water purification system, HWPS, designed for residential applications. Our technical director is Remedion's founder and CEO, Alexander Tompkins. Alex is an alumni of the University of Rhode Island, where he earned degrees in marine affairs and biology in 2022. During his time at the university, he gained firsthand knowledge of the microplastic and chemical pollution in our food and water supplies. In response, he designed solutions targeting pollution in aquaculture, hydroponics, bottled water, and municipal water supplies. After filing 4 patents for these systems, Alex founded Remedion to bring his innovations to market. I am the electrical engineer for the project. Michael is the computer engineer. Remedion's mission is to reduce pollutants in food and water through innovative, sustainable technology. By deploying its systems, expanding research efforts, and broadening system applications, Remedion is working towards its vision of an entirely pollutant-free food pyramid. Remedion is a clean tech startup with 4 patent-pending processes that remove contaminants from source water, serving applications in aquaculture, hydroponics, and direct human consumption. Remedion's technologies include the deep-water culture system for pollutant-free hydroponics, a water bottling system that removes microplastics, then bottles the clean water, the closed aquaculture system for shellfish depuration, pollutant-free fish farming, and the hydroelectric water purification system that co-generates purified water and hydroelectric energy. Currently, Remedion is working on farms that produce pollutant-free rice and tilapia, licensing the bottled water system to legacy bottled water companies to expand the availability of microplastic-free water, and deploying the whole home HWPS Michael and I worked on over the course of the ELECOMP program. Our project is driven by 3 core motivations: ensuring access to clean water at home, reducing the cost of water purification, and supporting sustainable living. Due to outdated plumbing infrastructure and limited regulations on emerging contaminants, most consumers remain unaware of the quality of the water they use daily. Tap water can contain a variety of harmful contaminants that pose risks when ingested, inhaled as steam, or absorbed through the skin. Recognizing that traditional purification methods are energy intensive, we've integrated power recovery technology into the hydroelectric water purification system. This system harnesses the kinetic energy of flowing water to generate electricity, enabling users to purify their water while positively impacting household energy consumption. By providing the cleanest water possible for drinking, cooking, and bathing, the HWPS empowers users to live more sustainably while protecting their health from both legacy pollutants and newly emerging threats. Our goal is to reduce long-term health risks by delivering safe, affordable, and energy-efficient water purification for every home. The anticipated best outcome for our project is the adaptation of Remedion's municipal HWPS design for residential applications. This would allow individual households to benefit from the same high-efficiency water purification and energy generation technologies that were previously limited to larger infrastructures. Throughout the project, Michael and I collaborated closely to develop and refine the system design, electrical integrations, and embedded software required to make this transition feasible. Our combined efforts were driven by the goal of fulfilling our ABO, ensuring that the adapted system would not only function effectively at a smaller scale, but also offer user-friendly operation and cost-efficient implementation for homeowners. Our team technical accomplishments are energy and pressure optimization, 3D CAD model development, firmware integration consultation, and companion app UI development. Our project will have profound and far-reaching impacts on both Remedion's business operations and the well-being of the end user. By introducing a whole-home water purification solution capable of addressing both emerging and legacy pollutants, Remedion is uniquely positioned to establish itself as a leader in the advanced water purification industry. For the end user, access to a comprehensive in-home purification system offers a tangible, everyday safeguard against the chronic health risks associated with long-term exposure to contaminated drinking water. By delivering water that is demonstrably free from pollutants, Remedion's technology empowers households to proactively protect their health. Furthermore, the peace of mind gained from knowing one's tap water is safe and clean could lead to broader lifestyle benefits. This includes reduced dependence on bottled water and a decrease in household plastic waste. In the long term, widespread adoption of Remedion solution has the potential to shift public expectations around residential water quality, establishing a new standard of health-conscious infrastructure in homes across the country and beyond. My work encompassed understanding the various components of the system and integrating them together. Starting from municipal water source, the water moves into stage 1, which allows for the capture of particulates greater than 5 microns. The second stage is absorption of chemical contaminants, i.e. chlorine. The third stage is biological sterilization. From here, it separates through the submicron filter into the 300-gallon water tank for household distribution. After the fifth stage, the water will be fed back into the system through a turbine, so there's a closed loop ensuring no waste of water. The water turbine will help supplement energy needs of the system, which is the water pump, which ensures consistent water pressure delivery to the home. I was in charge of creating a 3D model, developing system specifications, and power system design. The 3D model allowed us to be able to discuss and convey ideas regarding the format and flow of the system. It was also used as the deliverable for our engineering advisors in the company to create an initial model for testing. The system specifications component of my job involved understanding the impact of flow rate and how the water moved through the filter stages, and what kind of outputs we could expect. This involved analyzing water pressure, taking into account the various conditions as the system would be installed, and these constraints, among others, led us through various design stages to ascertain an ideal setup which would accomplish our goals while keeping costs down. Integrating the power system into the design required knowledge of hydrodynamics. There's only so much energy in the system to capture and repurpose, so we had to be diligent about where we were getting the energy from in the system and maintain awareness about how the extraction of energy affected the system. The overall idea is that the turbine captures the energy, the water pump consumes energy, and there's a battery to bridge the divide.
Thank you, Aaron. Aaron already walked us through much of the block diagram, but I'd like to briefly touch on the firmware components. As you can see, Team Remedion plans to measure the total dissolved solids, or TDS, at two critical stages. First at the water input, and again after the sub-micron separation stage, once the water has thoroughly been filtered. As a computer engineer on this project, I was responsible for developing the companion application that connects to the HWPS unit. I chose Flutter for app development due to its strong cross-platform capabilities. In addition to app development, I worked closely with our company advisors to establish the foundation for the firmware integration, specifically through a programmable logical controller, or PLC, and a human-machine interface, or an HMI. To support future scalability, I've already developed a functional application that will simplify the integration between our software and our hardware once the mass manufacturing begins. Let's take a closer look at how the firmware would integrate into the HWPS system. So we would plan to use an Arduino to collect data from the TDS sensors. That data will then be transmitted to an Allen Bradley MicroLogic PLC. It's a MicroLogic 850 on the right. The PLC will then process and store the data before sending it over to the HMI. The HMI will then sync with the app, enabling users to control the HWPS locally and receive real-time updates both on-site and remotely through the app. This structure ultimately ensures a seamless and intuitive user experience. Here on the left is the home screen I designed for the app. It clearly displays the water quality output and includes individual filter trackers at the bottom to monitor each filtration stage. I also integrated the app with Remedion's existing website, providing users quick access to customer support and more information about the company's vision for a sustainable and cleaner future. We would like to sincerely thank Dr. Sunak and Alexander Tompkins for the entire Capstone experience. Their mentorship and insights have been invaluable throughout the project. Thank you.